I want to talk about polyethylene. Polyethylene is a semi-crystalline solid and its crystallinity depends on defects in the polymer chain like branch points that prevent it from forming a crystal. Polyethylene is used in two main areas, which is durable and non-durable products. High-density polyethylene, which is HDPE, is made with metal complex catalyst and tends to be stiff and oriented in one direction, which is making it prone to be splitting. Low-density polyethylene is made at high pressure using free radical initiators and has a lower density due to its branch. But polymerization is a method where monomers are polymerized without any solvent using only a catalyst. For polyethylene, ethylene gas is polymerized directly under high pressure and temperature, with catalysts controlling the reaction. These are the fundamental principles of polymerization. The first one is monomer usage. Ethylene gas is the primary monomer and it remains in its pure state during the reaction. The second one, catalyst system. Catalysts such as Ziegler-Natta, metalloalkenes, or chromium-based systems are used to initiate and control the polymerization. The third one, reaction conditions. The process is conducted at high temperatures and pressures to maintain ethylene in a supercritical or liquid state. The last one, product formation. Polyethylene is formed directly in the reaction vessel, requiring minimal purification. These are as you guys can see, there are advantages and disadvantages of polymerization. The first one of advantages is high purity of product. The second one is simplified process. The third one is high monomer conversion, and the last one is energy efficiency. For disadvantages, the first one is heat management, the second one is risk of reactor fouling, and the last one is pressure requirement. But polymerization of polyethylene is often used to produce high-density polyethylene, HDPE, which is valued for its rigidity and strength. There are several products from bulk polymerization, which is containers and bottles, pipes and fittings, household goods, and the last one is industrial report. As you guys can see from the left, it is containers. To the right, we can see it is fittings, and the bottom left is cutting boards, and the last one is fuel tanks. That's all for me, thank you.
So my part is solution polymerization. Solution polymerization is a polymerization method which in the monomer, which is ethylene, catalyst and solvent are dissolved in a suitable liquid medium. This process typically operates at elevated temperatures and pressure. The polymerization reaction occurs homogeneously, meaning the polymer remains dissolved in the solvent during the reaction. So next is the key principles and conditions. The first one is temperature and pressure. It operates at high temperature between 120 to 250 degrees Celsius and the pressure between 10 to 50 bar. The second one is catalyst. It uses Ziegler-Natta or single-site catalyst for precise control over the molecular weight and polymer properties. The third one is solvent. A hydrocarbon solvent such as hexane or toluene acts as the reactant medium and prevents the polymer from precipitating. And the last one is monomer concentration. Its control level of ethylene are fed into the system for consistent polymerization. Next is the disadvantages. The first one is homogeneous reaction condition lead to the better control over polymer molecular weight and uniformity. The second one is it's produce high purity polyethylene with minimal branching, allowing for tailored polymer properties. And the third one is compatible with copolymerization to introduce additional functionalities, which is linear low density polyethylene, LLDPE. For the disadvantages, the first one is high operational cost due to the energy requirements and recovery processes. The second one is environmental disadvantages. The first one is high operational cost due to the energy requirements and recovery. For the next part is the real world example. For the linear low density polyethylene, LLDPE, the example is films, packaging, and stretch wraps. For the high density polyethylene, HDPE, the example is pipes, containers, and automotive parts. For the emulsion polymerization is heterogeneous polymerization method where ethylene and other monomers are polymerized in an aqueous medium containing surfactant. The reaction occurs in micelle forms by the emulsing agent with polymer chains growing inside the micelles. So the next part is the essential principles and factors. So the first one is surfactant. is essential for stabilizing emulsion and forming micelles. The second one is initiator, which is water-soluble free radical initiator, which is potassium persulfate, are used to trigger the reaction. The third one is pressures and temperature. It's generally conducted at moderate condition, typically between 50 to 90 degrees Celsius and lower pressures than solution polymerization. The last one is reaction medium. Water serves as the main medium, making the process more environmentally friendly. Okay, so for the advantages, the first one is water-based process eliminates the need for organic solvents, reducing environmental impact. The second one is efficient heat dissipation due to the aqueous medium, minimizing temperature. So for the disadvantages, it's limited to the certain polymer type and not ideal for very high density polyethylene. The second one is requires additional steps to remove surfactants and residual emulsifiers, increasing processing complexity. And the last one is potential for impurities that affect the polymer's physical properties. So this is the examples of products and application. It is linear low density polyethylene, which is LDPE. It's used in adhesive coatings and films. For the application, it is used in the latex-based coating, water-resistant films, and textile finishes.
Suspension polymerization is a polymerization technique where the monomer is dispersed into small droplets within a continuous liquid phase, typically water, to form a suspension. The reaction occurs within these droplets, leading to the formation of solid polymer. We go to the suspension polymerization method of polyethylene production. Okay, the first one is monomer dispersion, where the ethylene gas is dispersed into tiny droplets within the aqueous phase using mechanical stirring or emulsifying agent. And then the second one, initiation. A catalyst such as a Ziegler-Natta or metal-locking catalyst is introduced. The catalyst is either soluble in the monomer phase or anchored to small solid particles within the droplets. The third one is polymerization, where the polymer chain from inside the monomer droplets, creating solid polymer particle. Heat generated by the exothermic reaction is absorbed by the surrounding water, maintaining the temperature control. And the last one is product recovery. Solid PE particles are separated, washed and dried for the further.
Then we go to the fundamental aspect of suspension polymerization. The first one is physical system. The monomer is suspended as droplet in an aqueous medium. Second one is stabilization. Stabilizers such as surfactants or protective colloids are used to prevent coalescence of the droplets. The third one is catalyst. A polymerization catalyst initiates chain growth inside the droplets. And then the temperature control. The water phase efficiently dissipates heat, minimizing the risk of runaway reaction. The last one is resultant product. Discrete polymer particles are formed to reducing the need for additional size
These are
control
the
steps.
list of the advantages and the disadvantages. Gas-phase polymerization is a widely used method to produce polyethylene, especially linear low density polyethylene, LDPE, and high density polyethylene, HDPE.
There are 5 gas-phase polymerization methods. Okay, we go to the first one is reactor setup. Reactor setup is a fluidized bed or stirred tank reactor containing a bed of catalyst particle. Second one is polymerization process, where the gases monomer like ethylene and possibly comonomers such as 1-butane or 1-hexene are continuously fed into the reactor. And the third one is catalyst activity. The polymerization reaction occurs at the surface of solid catalyst, forming polyethylene in granular form. Next, for the fourth one is heat management. The heat from the exothermic reaction is managed by circulating the gas and removing excess heat. And then the last one is product recovery. The granular polyethylene is periodically removed, while unreacted monomers are recycled. Now I'm going to talk about core principle and condition involved in gas-phase polymerization. The first one is monomer phase. The monomer exists in the gaseous phase, ensuring direct interaction with the catalyst. And then catalyst. Ziegler-Natta catalyst or chromium-based catalyst or metal-locking catalysts are commonly used. And then fluidization. In a fluidized bed reactor, gas flow ensures that the solid catalyst particle remain suspend and evenly mix. And then temperature and pressure. Is a typical operating condition include moderate pressure between 10 to 30 bar and temperature between 70 to 110 degree, and then continuous process. The last one is the process is highly efficient due to continuous feeding and product. And then temperature and pressure. Is a typical operating condition include moderate
Here
pressure.
are the advantages of gas-phase polymerization. The first one is energy efficiency and then simple process design. The third one is environmental friendly and high polymer quality. And the last one is
Now we go
to the disadvantages, which is the first one is heat management challenge, and the second one is catalyst sensitivity, and the last one is limited
Here
monomer.
are the HDPE application for the LLDPE application and product.
3B. So today I want to present about compare and contrast. For polyethylene is widely used polymer and its production can involve different polymerization method, each with unique feeder and mechanism. We have 5 methods, which is free radical polymerization, Zeitlin-Natta polymerization, metallocene catalyst polymerization, solution polymerization, and gas phase polymerization. For free radical, the key product is LDPE. Pressure and temperature is high. Advantages simple and cost effective, and disadvantages low control over structure. For Zeitlin-Natta, the key product is HDPE, and the pressure is low and temperature moderate. Advantages high crystallinity, specific design. Disadvantages catalyst sensitivity. Metallocene catalyst, HDPE and LLDPE. Pressure and temperature moderate and moderate. Advantages tailor and properties. Disadvantages high catalyst cost. For solution, the key product is LDPE and HDPE. The pressure and temperature moderate, and advantages uniform properties, good heat control. For disadvantages, solvent recovery to complexity. For gas phase HDPE, the pressure and temperature is low. The advantages of gas phase is energy efficient and scalable. For disadvantages, require advanced reactor design. For the strength of production method, high pressure polymer, we have 2 of this polymerization process. For high pressure polymerization, produce LDPE, which is flexible and widely used in film and packaging, allow for easy scalability in industrial production. For gas phase ancillary polymerization, efficient for producing high density polyethylene and linear low density polyethylene, which is LLDPE, which have excellent mechanical. Second, processing method: extraction, blow molding, and injection molding. In extraction, suitable for creating film, sheet, and pipe with consistent quality. And second, continuous production process that minimize waste. For blow molding, ideal for creating hollow product like bottle and container. Cost effective for large scale production. Injection molding produce complex shape with high precision and excellent surface finish. Fast cycle time, suitable for mass production. For the strength of production method, high pressure polymer, we have 2 of this polymerization process. For high pressure polymerization, produce LDPE, which is flexible and widely used in film and packaging. Third strength, it is recycling method, which is have mechanical recycling and chemical recycling. In mechanical recycling, cost effective and widely adopted, extend the life of polyethylene product by reprocessing them into pellet for use. In chemical recycling, break down polyethylene into its monomer, allowing for high quality recycled material, and it can process meat or contaminated plastic, which are not suitable for mechanical recycling. In application specific consideration, polyethylene is lightweight, durable, and resistant to chemical, make it versatile for packaging, construction, medical, and consumer goods. And its recyclability, if properly handled, make it potentially sustainable material. Third strength, it is recycling method, which is have mechanical recycling and chemical recycling. In mechanical recycling, cost effective and widely adopted material. For weakness in production method, we have three, which is energy consumption, catalyst sensitivity, environmental impact. First, high pressure polymerization required significant energy input, leading to higher production cost and environmental concern. For catalyst sensitivity, some process require highly specific catalyst, which can be expensive and sensitive to impurities. environmental impact, production method generate carbon emission and rely heavily on fossil fuel. For second, processing method. Material we have three also, which is material wastage, energy use, and tolling cost. Some methods such as injection molding can result in material wastage due to sparks and runner. For energy use, this process often consumes significant amount of energy depending on the scale and equipment used. For tolling cost, initial cost for mold and die can be high, and practically for injection molding. Third, recycling method. We have two, mechanical recycling and chemical recycling. For mechanical recycling, degrade polymer quality with each recycling cycle due to thermal and mechanical stress. And secondly, limited to relative clean and sort with stream. Chemical recycling, expensive and energy intensive compared to mechanical recycling. And secondly, still under development for large scale application. For fourth, application specific consideration, non-biodegradable, contributing to long-lasting environmental pollution if not recycled. Susceptible to UV degradation unless treated stabilizer. Some applications require additive which complicate recycling effort. Application and industries, we have 5, which is first, packaging, bottle and film. Secondly, medical and healthcare. Third, pipe, hose and fitting. Fourth is household product and consumer good. For lastly, wiring and cable. In industry, packaging, bottle and film, HDPE is widely used to manufacture crate, trail bottle caps, drum. LDPE is majority used in film, plastic bag, trash bag and other food packaging material. Such as we take of LDPE, we take plastic bag and food packaging. For secondly, medical and healthcare used to create medical products such as pads, personal protective equipment, packaging film and container, lid stock and bed header. We take example of patch and personal protective equipment. Third, pipe, hose and fitting. We take PE pipe used in gas pipe, water pipe, sewer pipe house, thus offering excellent resistance to chemical and hydrolysis. First, we take the example is gas pipe and water pipe. For fourth, household product and or consumer good, with garbage the example of is garbage container, kitchenware, houseware, icebox, bowl, bucket, ketchup bottle. So the example we take is garbage container and kitchenware. For lastly, wiring and cables, cross-linked polyethylene or polyethylene copolymer resin are useful for wire and cable insulation and jacketing. The example we take here, wire and cable. For lastly, advantageous method we take is gas phase polymerization. For general purpose HDPE or LLDPE, gas phase polymerization is the most cost effective and versatile. And secondly, for flexible and lightweight LDPE, high pressure polymerization is ideal. And lastly, for specialty or premium polyethylene grade, metallocene catalysis polymerization offer the best performance. For conclusion, to sum up this polymerization polyethylene method of polyethylene production, each polymerization method for polyethylene production has unique strength and weakness, thus making them suitable for different applications and industries. High pressure polymerization is ideal for producing flexible low density polyethylene, which is LDPE, while gas phase and slurry polymerization are widely used for large scale production of highly density polyethylene, which is HDPE, and linear low density polyethylene LLDPE due to their efficiency and versatility.